devoted all of my adult life to this subject. I only debate with my equals. All others I teach.
We think that they are foolish to allow themselves to be beaten and brutalized and do nothing whatsoever to protect themselves. They are foolish. They should have the right to defend themselves against any attack made against them by anyone. If a dog is biting a black man, the black man should kill the dog. Whether the dog is a police dog, a hound dog, or any kind of dog. If a dog is sick on a black
What's up? What's up? So, it's been a long time, man. Missed you guys. Hope you missed me. I'm back at it again. So, I did a video. I don't know if you guys caught it or not, but I just go into, how we look at species, right? And what I really wanted to do is just really get into the basics of it, because we jump into these conversations not really defining terms so we can all be on the same page. So I think it's really insurmountable, that we all get on the same page about these issues and what we actually are talking about. You know what I mean? So that's what I want to do. I got a little slideshow for you guys, and I just want to take a look at the differences between facts and a theory. Right. So when we got a theory, we have organized facts, right? A scientific theory is the facts organized, right? So, but we got to take into consideration how these facts are interpreted, right? We have to take into consideration how the facts are framed. So that's what we're going to look at today, how the facts are being framed and how they affect us today in determining what is and what not is a species, how you determine species, right? So let's see. We're just gonna get right into it. Share this for you guys. So now we talk about species, right? And I wonder if how many people actually know that there is no scientific consensus on the definition or the concept of species, right? There's no consensus on it. So how do we know we're even talking about the same thing, right? How do scientists know that they're even talking about the same thing, right? You have over I believe 30 different concepts. I don't know how many different definitions of what a species actually is, right? And my question to you is, if we can't define it, right, and we don't even have a concept for it that's accepted universally, then how do we have these conversations? Like, how do we determine, how do we go about having these conversations, like if the terms aren't even defined? So what we end up doing is we end up using these placeholders, right? And then when we talk to each other, we can actually be talking past each other because we're looking at species in different ways. And then also you got to take into consideration that species we're not just talking about humans, we're talking about all biological organisms, because most, if not all, biological organisms have different species, right? So we need to have a definition that we can, stand on to where we can qualify and classify these different things that we are calling so-called different things. How else do we know that these different things are different things if we don't have the method? That is what's in question right now, right? We are questioning the methodology, right? Where is this coming from? We're scrutinizing the jargon, right? Because the jargon can be confusing also. So here are the four major biological concepts, right? These are the four ones that are mainly used, but there are plenty more, right? The species problem. Difficulties arise in defining and categorizing species, as different concepts can lead to varying criteria and conclusions, right? So based on the definition and the concept that you use, you can be led to a different conclusion from other people. So how do we determine who's right? This water is about to get so murky, you guys. I'm talking about so murky, right? You have biological species concept, right? Define species based on ability to interbreed, right? That's supposed to be one of the criteria, right? Supposed to be. We got morphological species concept, define species based on physical traits. That's supposed to be another concept. You got ecological species concept, define species based on ecological role. And you have the phylogenetic species concept, define species based on evolutionary history. But what a lot of people don't know about these is that all these concepts overlap one another, right? You have these conflicting theories, right? And it kind of bogs down progress, right? Because we don't know if we're even talking about the same thing. Now, I want to share with you guys an article that I found really insightful. I found it really fascinating, and it really breaks down what we're going to talk about. It really breaks down really what I want to go through, and it's an article from an archaeologist. Let's see if I can find it right quick. Where is that thing at? Let's see. Right here. So if I go here. Mm-hmm. All right. So here we go right here. So this article was really refreshing to me whenever I first read it. The guy's name is Jeffrey H. Schwartz. He has a doctorate from Columbia. He also has a bachelor's from Columbia, and he's an archaeologist. An archaeologist. So let's just go through the article that he wrote. This magazine, you see the source right here is from a magazine called Sapiens, right? So the article is called "The Humans We Haven't Met Yet." One anthropologist contends that far too many species have been lumped into one category. Our story is more complicated, he argues. So let's get into it. Everything that's been called Homo sapien isn't. In my opinion, far too many species have been lumped together into one taxonomic category. The truth of the human story is far more complicated, with more species and even more genres than have been named, and more dead ends on the branches of the human family tree that have been recognized. As an evolutionary biologist, that's what he is. As an evolutionary biologist, I've always been interested in the theory and practice of how one defines species and tries to figure out its evolutionary relationships. I came to understand that this process is only ever hypothetical, never provable. That's coming from an evolutionary biologist with a PhD, right? A lot of this is hypothetical, not that we don't have facts, but the stories that we come up with around it and how these things come about, right? I began in the 1970s studying early mammals, then lemurs, and then other prosimians, then apes. I stayed away from hominins at first. There was too much storytelling and not enough evidence for my taste. But my frustration with how the human fossil record was interpreted pushed me into this arena in 1997. My first goal was to put together an encyclopedia of as many human fossils as I could get permission to study. This led to 3 volumes, the last published in 2005, right? Since then, I've continued to document the human fossil record with detailed descriptions and lots of photographs. And the more specimens I studied, the more I realized that most of the species designations don't make sense. That's from an evolutionary biologist, right? He came to the conclusion, the more that he studied, the more that he realized most of the species designations don't make sense. If hominin fossils were treated the same way as non-human primates, specimens currently lumped into the same group will be allocated to different ones. We need to go back to taxonomic basis, and that's what we're doing today. We're going back to the basics and see how they are using these methods to qualify these different organisms, right? Having studied so many human fossils is both a blessing and a curse. The blessing is that I can apply my theoretical and comparative background to virtually the entire human fossil record. The curse, I don't always see eye to eye with other paleoanthropologists who often focus on 1 or 2 species, a geographic area or a period of time, right? And that's the issue with the field of study in general. Paleoanthropology, anthropologists, genetics, man, there is no consensus on a lot of this stuff. It's people trying to push their narratives, whatever it may be. I understand that science tries to be objective, but a lot of times, people are pushing their narratives, right? Everybody wants to be right. We humans are the only surviving species of our intermediate evolutionary group. This often leads people, including researchers, to make intuitive but not necessarily correct assumptions, right? The closer one gets to the present, the fewer contemporary species there should be, in theory. To track how this came to be, we could start in 1735, where Carl Linnaeus published System of Nature. There he classified each plant and animal he knew of using a new strategy, the couplet of genus plus species. He also insisted that the genus and its subordinate species be defined or diagnosed through specific morphological or behavior features, and not as was common by some feeling. So back in the day, right, in the 1700s, right, the mid 1700s, they was just classifying these things willy-nilly. And it's not so much different today, right? He said it used to be feeling, and then he came up with a method, and he said morphological should be a one method, and or behavior features, right? Was the terms that he came up with to classify different things, right? So the phenotypical features and the behavior features are nowadays what's common on how you classify fossils. Now we got more today, considering we got genetics. That's the latest thing. We'll get to that in a minute. Yet when it came to Homo sapien, Linnaeus ignored his own requirement. Instead of providing a morphological diagnosis of Homo sapien, he let us define ourselves with the phrase "Nos te ipium," know thyself, right? This notion of "I know it when I see it" still informs today how hominin fossils are allocated to our species, A. sapiens. So he came up with a method, right, to classify different organisms. But when it came to the category of the Homo sapiens, he said, use this method. I know it when I see it. How crazy is that? And this is legit science, right? At the time, right? And you got to think, this was the guy who created the taxonomy, right? He's the person that started lumping these people into groups. So some of these things still exist in the same categories from back then. There have been revisions of these categories also throughout time. I believe we'll get to that later on. Although rock hard objects with the shapes of bones and teeth had been unearthed for centuries, only in the 1600s did Nicholas Steno, a Danish scientist, convince skeptics these were the fossilized remains of extinct animals, right? For Western European, this was a big deal. In the eyes of Stuart creationists, God would not have allowed animals to go extinct. While first human-like fossils were discovered in 1829, it took decades before the possibility of antiquity was even discussed, right? So this field, right, is pretty much only like 100 years old, a little over 100 years old. The first publicly debated human fossils were discovered in 1856 in Germany, and this was the Neanderthal, right? When creationist and anatomist Hermann described these bones in 1857, he argued that they were fossilized remains of some brutish race that preceded living humans. In 1864, the geologist William King created a new species named for them, Homo neanderthal. So, and for the most part, this went on for decades, for dozens of years, on how they was classifying humans. We like to call this lookership, right? Picking it up out the ground and saying, this looks like this, right? And imagine the beginning to where you don't have nothing to compare it to. So you found the first Neanderthal bone, right? And said that, let's say it's a Neanderthal skull, and you just was like, yeah, this is an early human. That's literally what they did. The late 19th century and early decades of the 20th century witnessed a rash of discoveries of now accepted human-like fossils. This included more Neanderthals, Cro-Magnon, and other Upper Paleolithic Homo sapiens, right? And even the new genre. Indeed, from 1864 to 1949, paleoanthropologists named at least 9 human-like genera and 12 species, right? As early as 1933, physical anthropologist Solly argued that Neanderthals and whatever this one is called, I'm not even going to attempt that, and a skull from Zambia dubbed Homo rhododendronus were morphologically so different from the Upper Paleolithic Homo sapiens, they didn't belong in the Homo genus, in the genus Homo. In 1940, he suggested that this broader Neanderthal-like group deserved its own genus name, right? So he separated. He said the Neanderthal and the Homo sapiens look so much differently. We need to give them their own category, right? Just by morphological features. So while paleoanthropologists were latecomers to fossil hunting in the 1800s and the 1900s, the emerging picture was that human evolution was taxonomically diverse and species rich, just like other animals, right? So they were saying that in the early 1800s and 1900s that there was a variety of different humans, right? It was a variety, just like whenever you look at primates, a variety of different primates, a variety of different type fish, whatever that genre is called, whatever that is called. But this picture began to change in the 1940s. In 1944, with World War II raging, pioneering Ukrainian geneticist Theodosis Dobb argued that humans evolved in a different way from other animals because of culture. Instead of different species emerging as humans adapted and evolved to suit different particular circumstances, culture allowed humans to alter their environment to suit them. This was very early on in the evolution of human populations may have begun to speciate. Culture stopped the process, right? He's saying culture stopped us. We was able to create technology and alter the environment, so we didn't have to adapt ourselves, right? That's his argument. Therefore, he argued the picture of human evolution was not one of diverse species, but a single variable lineage that changed over time, right? His argument was, in part, a critical response to the Nazi belief in inferior races, right? In 1950, taxonomist Ernest Mayr formalized Dobbs' no speciation notion by collapsing all human fossils into a genus Homo and 3 chronologically defined transition species, right? The Transylvanian, which is the oldest, the Erectus, the middle, and the Sapien, the youngest. That was all, right? It was these 3 kinds of humans. That's it, right? They were thought to have marched from one species to the next in a chronological order, a chronological simple line. In doing so, Mayr demoted previously noticed differences between fossils to just individual variations in species. So before we had these differences among Cutians, right, and we called it variation, right? In doing so, Mayr demoted previous noticed differences between fossils to just individual variation within species, right? He said, no, this is different kinds of the same thing instead of different species. Homo sapiens now included us, Upper Paleolithic humans, Neanderthals, and specimens previously attributed to Homo rhododendronus, Homo heidelbergensis, and Paleoanthropus, echoing Dobbs. The underlying message was, if all these morphologically desperate hominins were members of the same species, how could anyone think that the differences between them and humans races were evolutionary meaningful? Meaning, bet. I'll say you, Jay. So, meaning that we have these differences between us today, right? And if these differences back then aren't meaningful, then they damn sure are not meaningful today, right? And as the number of morphological desperate specimens in each species grew, so too did the wonderment at how incredibly variable each species was, right? In order to acknowledge the marked differences between human samples, paleoanthropologists in the 1960s began divvying Homo sapiens into archaic and anatomically modern humans, right? They started separating humans, right, in the 1960s. They was all lumped into each other, and then they started separating them again. Archaic subsumed Neanderthals with their low rising brows, often long brain cases. Archaic subsumed Neanderthals with their low rising, often long brain cases, rounded brows, and large puffy projecting snouts. It included Homo heidelbergensis with its robust lower jaw, and like Zambian H. rhododesis, it included skulls with sloping profiles, thick brows, and chunky faces, right? Anatomically, modern humans were chronologically younger and included the upper Paleolithic humans and specimens from various Levantine and African sites with slightly rounded skulls, slightly bulbous frontal bones, less robust brow ridges, and sometimes smaller faces, right? By 1990, Neanderthal was firmly reinstated as a unique species. Not long after, most paleoanthropologists agreed that other archaic specimens should be removed from Homo sapiens and placed in heidelbergensis. Even absent these specimens, Homo sapiens was still a motley lot. Take, for example, the skull V individual, right? This specimen dating to around 100,000 to 81,000 years ago from the Skull Cave, Israel, is part of a group of skeletons excavated in the late 1920s to the early 1930s that were named Paleoanthropus, Paleostenus. Because of Skull V's protruding face and prominent brow, anthropologists of the time thought his species bridged the gap between Neanderthal and Australians, right? The Aborigines. After 1950, the skull specimens, like so many, was lumped into Homo sapiens. So here again, they lumped them back into Homo sapiens. Yet, in addition to his prominent brow and protruding face, in 2015, researchers pointed out the skull V's long, shallow plate would not have housed a short, thick tongue like ours, and based on aligning the neck vertebrae, its voice box lay behind, not above its breastbone. In short, this individual did not look like us, and it could not produce the basic sound of human speech. So why is Skull V still considered a member of Homo sapien? It beats me. This is from a biological anthropologist. So he said that we still have skulls that's in the Homo sapien family that are not like us, that's considered Homo sapiens. But why? Why? Skull V and many specimens still classified as Homo sapiens are about as different from us as Neanderthals are. Having studied them all, it seems the only thing we could have in common is that we don't have long brain cases with sloping foreheads. For my decades-long study of recent human skulls from all continents, I say Homo sapiens have a few key physical features. There is no continuous brow above the orbital sockets and across the nasal region. Our lower face is vertical and a lot narrower across than our cheekbones. You can feel this yourself. Most importantly, we're the only living mammal with a true chin, not just a bulge, but an upside down T shape that often becomes triangular as a person grows older. Using such features to define Homo sapiens, many fossils, including the Skull V, as well as Omo 1 and 2, and those of Herto, Ethiopia, don't make the cut. If we use that as the criteria, they don't even make the cut as Homo sapiens, right? These are the morphological features. All European upper Paleolithic humans, on the other hand, such as Cro-Magnon, do all have these features. So why aren't they Homo sapiens, right? Cro-Magnon is not a Homo sapien, but it has a lot of the same features as Homo sapiens, and there's ones that don't are considered Homo sapiens, but the Cro-Magnon is not. Why? I would say the oldest collected specimens of Homo sapiens is from a Broader Cave, South Africa, which is perhaps as old as 174,000 years. I'm gonna let you in as soon as I get finished reading. In my view, the pot currently held Homo sapiens contains specimens representing at least a few species, right? In my view, the pot currently held Homo sapiens contains specimens representing at least a few different species, and these species are our closest extinct relatives, even closer than Neanderthal and the recently described dragon man proposed as Homo longi from China. So this man says in the Homo sapien catalog, right? We have in the Homo genus, in the Homo genre, we have a closer ancestor probably than Neanderthal, but just being classified as something else. That's what he's saying. Many people think that DNA accurately reveals the pictures of human evolution, but this is not true. First of all, DNA has only been successively extracted from a handful of fossils. So out of all the fossils that we have, DNA has only been extracted from a few of them. Not many at all, less than 1%, including some Neanderthals. Some upper Paleolithic and near recent humans, a partial finger bone from Denisovan cave, and 2 bones from Cima de los Huos, Spain. Since DNA usually degrades within about 100,000 years, we'll only ever have DNA from a minuscule fraction of fossils. DNA analysts are missing most of the pieces of the puzzle, and there are circular arguments. Now, this is going to be wild right here. DNA is identified as, say, Neanderthal because the fossil was identified as such. And then it is used to identify other fossils as Neanderthal, even if they don't look like Neanderthal, right? So he said we identified the fossil first as Neanderthal because DNA wasn't there at the time. So now we have to kind of stick to the script, right? And so we have found other fossils with the same DNA as the classic Neanderthal, but they don't even look the same, right? But in a different morphological concept of what we consider species, they wouldn't be Neanderthal, right? While certain similarities between our DNA and Neanderthal DNA have been interpreted as evidence of two species interbreeding, these similarities could just be run-of-the-mill features of the genome common to many species. Let me run that back, right? Because people try to say that since Neanderthals and humans share some DNA, since Neanderthals and Homo sapiens share their DNA, that they interbred with each other, right? But not according to this biologist, right? Not according to this archaeologist, right? He says, while certain similarities between our DNA and Neanderthal DNA have been interpreted as evidence of two species interbreeding, these similarities could just be run-of-the-mill features of the genome common to many species, right? We don't know that, right? But that's how it's interpreted, right? Because we're talking about how we are framing the facts, right? How we are interpreting the facts, right? We have to interpret it because the fossils don't tell the stories themselves. We make the story, right? In the quest to embrace interbreeding as the source of human Neanderthal molecular similarity, people sometimes forget to ask the question: if humans and Neanderthals actually cross paths as often as molecular anthropologists claim, which is not supported by archaeology or paleoanthropological evidence, would they have recognized each other as potential mates? I don't think so. They look too different. Even present-day hunter-gatherers groups have been observed to engage in violence when they encounter each other. And there is evidence from the 49,000-year-old site, Sidron, that Neanderthals cannibalized other Neanderthals, right? So when Dahl first kicked back against the taxonomically diverse picture of humanity, his ideas conveyed the well-intended implication that if specimens widely different as Neanderthals, Homo rhodonensis, and modern humans all belong to the same species, differences between living humans become insignificant, right? Right? We all are one, absolutely equal, no lesser group among us. This is true, of course. All modern humans are clearly morphologically Homo sapiens, but our present world should not cloud our view of the past. While Dove's reaction to the Nazi ethnic cleansing was commendable, the legacy he left, which Mitre translated taxonomically, still constrains how many paleoanthropologists viewed the later phases of human evolution more linear than species rich. To me, however, all of human evolution, even what after our own species first emerged, is a mess of branches and dead ends. Our evolutionary history is complicated, and we should embrace that, right? So I think this was a very, 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 very refreshing article. And that was the name. His name is Jeffrey H. Fultz. He got a doctorate, and he has a bachelor. So let's go back. Now, I guess Pan African James. What up with it, Sadiq? That was written in, I think I just closed it out, but you can come on, Jay. I think this was 2020 that it was written in. 2021, maybe. Let me see. This was 2021. It was written in 2021. All right. James read that article. Well, dang. I wonder why he didn't come up. So this is what we're gonna do now. We're gonna kick this off. And that's gonna set the tone for what we're about to do as far as different species is concerned, right? So now we have the species problem, right? Because we're talking about all these different ways to classify species, right? Because there is no universal consensus, right? There is no universal consensus. There is no one definition, and there's plenty of biological concepts. So these are the four main concepts that they use, and they overlap and they conflict sometimes, right? Let me make sure James ain't in the back. All right. So, and they conflict sometimes, right? So let's read this. The species problem. The species problem is a set of questions that arises when biologists attempt to define what a species is. Such a definition, called the species concept, there are at least 26 recognized species concepts. A species concept that works well for sexually reproducing organisms, such as birds, is useless for species that reproduce asexually, right? Such as bacteria. The scientific study of these species, the species problem, has been called microtaxonomy. One common but sometimes difficult question as to how best to decide which species and organisms belong to, because reproductively isolated groups may not be readily recognizable, and cryptic species may be present. There is a continuum from reproductive isolation with no interbreeding to pandemics, unlimited interbreeding. Populations can move forward or backwards along this continuum, at any point meeting the criteria for one or another species concept and failing others. Many of the debates on species touch on philosophical issues such as nominalism and realism, and on issues of language and cognition. The current meaning of the phase species problem is quite different from what Charles Darwin and others meant by it during the 19th and 20th centuries. For Darwin, the species problem was the question of how many species arose. Darwin was, however, one of the first people to question how well defined species are, given that they constantly change, right? That's an issue that we got to contend with. We really got to contend with this ever changing idea of what a species is. And people think that they know, and we go along with these conversations, but you really don't. And I'm here to show you, right? So here's some other species concepts that we use, right? Biological, we deal with these for the cohesion species, right? Persistence of discrete phenotypes, right? Ecological species concept, right? Evolution species concept, the plural species concept. How do we know which ones to use, right? But let me show you what some of the issues are with these concepts, right? So the biological species concepts deal with reproduction isolation, right? Basically, if two species can reproduce, then they the same species, right? Well, it doesn't work for fossils or asexual species, right? Because you can't really tell with fossils, right? And then what about asexual species that don't need a mate to reproduce, right? What about the morphological species concept, which deal with physical traits? Well, it's subjective and prone to misclassification because we have variety among humans, we have variety among species. So variety of morphological phenotypical traits don't mean different, don't mean substantially different, don't necessarily mean different species. You can have different species in the same ecological system that look completely different but can mate with one another, right? So we just can't split them up, dealing with how they look. Uh, Phylogenetic species concept, right? When we use the common ancestry class, this depends on the tree resolution and available data, but the tree can be highly subjective, right? Because depending on which method that you use, your trees will be different, right? Your ancestry will be different, right? Ecological species concept. This is about, the environment. This is hard to measure and it can overlap. You have these gray areas that overlap often, right? And that's what we just went through. I was trying to go back up. Let me see. My computer is moving kind of slow. Trying to go. There we go. All right. So let's go to the next one. All right. This is the article that we just read, right? And our story is more complicated. One anthropologist contends that there are far too many species have been lumped into one category. Our story is more complicated. That was his premise, right? And he broke that down. Well, let's deal with one of the facets that he said. As an evolutionary biologist, I've always been interested in the theory and the practice of how one defines a species and tries to figure out its evolutionary relationships. I came to understand that this process is only ever hypothetical, never provable. Why, you may ask? Why is it highly hypothetical and never provable? Well, let's go through the motions, right? Species are not fixed entities. Did you know that? Evolution is a continuous process, not a series of clean breaks. So what do I mean by this, right? Evolution is a continuous process, not a series of clean breaks. So if it's not a series of clean breaks, how do we know how to discern from when a species turns into something else? We already established, we can't just look at it. We already established that genetics, you can't use genetics, right? Because there's no genetic marker that says this is a substantial change and now I'm something else, right? Because we just looking at markers, and a lot of times when you're looking at just DNA markers, it might not even be expressed phenotypically, morphologically. It could be something else expressed in a different way. Have something to do with your organs. You know what I'm saying? Internal traits. Populations can gradually change over time through mutation, selection drift, gene flow. This makes it difficult to draw a hard line where one species ends and another begins, especially in the fossil record. Trying to define the exact moment a color gradient shifts from blue to green, right? Trying to define the exact moment a color gradient shifts from blue to green. That's essentially what we're trying to do, right? And who is the authority to say when something is completely different, right? That's what you have to ask yourself, right? Who's the authority on that, right? Or is people just, guesswork? What else could it be, right? So we're going to talk about these things, right? We're going to talk about mutation, selection, drift, and gene flow, right? Because a lot of people really don't know what these mean because they talk about it, but they don't know how it's applied, in science. So mutation is random changes in DNA. Why it complicates taxonomy. Mutations introduce new traits and genetic variations within a population. Over time, this can cause populations of the same species to diverge significantly without necessarily becoming reproductively isolated, right? So you can have a random mutation, right, of the same species, but whenever you look at it in the fossil record, you would think that it's something else. By just looking at the fossil record, you can have over time, this can cause populations of the same species to diverge significantly without necessarily becoming reproductively isolated. meaning that they can still mate. Example, in bacteria, frequent mutations can create variants that are morphologically and functionally different, but still part of the same species, according to some definition. And that's micro, but you have it also in the macro. We're going to go through that also, right? Natural selection, right? The process by which traits improve survival and reproduction become more common, right? Why does it complicate taxonomy? Selection can drive rapid changes in phenotype, observable traits, creating distinctive looking populations that still may interbreed. Here we go again. This can cause taxonomists to wrongly classify them as different species based on appearance, right? Let's give an example. African cheetah fish have rapidly diversified in the same lakes into many forms due to ecological selection, but often can still interbreed, right? So you can have extremely diversified appearance and still be the same thing. Natural selection. So we talk about these things and act like we know, but do we, right? What about genetic drift? Random changes in gene frequency due to chance events, especially in small populations, right? Why does this complicate taxonomy? Drift can cause two populations to become genetically distinct without any adaptation or reproductive barrier. This makes it hard to judge whether they are truly separate species or just isolated groups. Example, two island populations of birds may become genetically different due to drift, but still able to interbreed if brought together. Dang. Gene flow and migration. Gene flow is movement of genes between populations through interbreeding. Why does this complicate taxonomy? Gene flow blurs the lines between populations, maintaining genetic similarity and making it hard to define clear species boundaries. Species that appear distinct may still exchange genes, creating hybrid zones. Example, wolves, dogs, and coyotes are often considered distinct species, but they can't interbreed and produce fertile offspring, complicating their classification. Same with humans. Are you guys with me? Let's go. So this is the visual, right, of gene flow, right? You have this barrier, and you don't even necessarily have to have a barrier, but they're using this water like this is a barrier for birds. This wouldn't be much of a barrier for birds, but you have two distinct populations, right, that's going back and forth, intermixing, and which is fogging up, muddying up the water and genetics. So whenever you look at them, you think they might be different, distinct species, but they're not, and they're able to interbreed. So depending on how many of the little A's come into the big A's, you can either change the big AA population can change, or if the big AA population a lot of them go to the small AA population, it can change that population. But are these two distinct species if they can breed, right? And what about the babies from the AA little and the big capital AA big? What the hell are the babies? Is that a new species? We got to cut it out. Gene flow, right? This is another example, a visual for gene flow, right? All right, just making sure. What's up with it, Dominique? All right, let's keep it moving. All right. The fossil record is incomplete and biased. Fossil rarely preserve the full picture, only fragments. There's no DNA for most extinct organisms. Did you know that? We're not even using DNA on most of the fossil record. So what is it? It's lookership, looking at it and classifying through looks, right? Limb proportions and all that type of stuff. But we have so much variation. So it's hard to do it, but humans have the tendency to classify according to how things look. We are pattern recognition organisms, right? Pattern recognizing organism. We want to always group things on how similar they look and, act like they're the same. But let me tell you, nature is not classifying things on looks. Humans are. Transitional forms may go undiscovered or be too fragmentary to interpret. Evolutionary relationships are reconstructed from partial data using inference, not certainty, right? Let's keep it moving. Let's talk about DNA, right? DNA is identified as, okay, this is from the article, right? I want to read this again, and we're going to talk about how this is problematic, right? DNA is identified as, say, Neanderthal because the fossil was identified as such. And then it is used to identify other fossils as Neanderthal, even if they don't look like Neanderthal. Did you know that, right? We have these fossils that have been identified as Neanderthal. And then we say, okay, we look at the DNA and we say, this is Neanderthal DNA, right? And then we have other fossils that we have identified through DNA that say this is Neanderthal, but it don't look nothing like the other Neanderthal fossil. How do we discern? Is this different species in the Neanderthal, or is this the same thing with variation of morphology? That's the question. While certain similarities between our DNA and Neanderthals have been interpreted as evidence of the two species interbreeding, these similarities could just be run-of-the-mill features of the genome, common to many species, right? And here's another thing that you got to think about. We cannot possibly find every extinct human or anything else that's extinct. So there's going to be gaps in the information. So I believe sometimes people hold the bar too high, right? They'd be like, where's the transitional fossils? Where's the transitional organism? And it might not even be no transitional organism, or you might be looking at it already. And we can't possibly find every single extinct so-called human ancestors, right? We ain't gonna find every one of them, right? That's just a silly thing to ask. Phylogenetic trees are hypotheses. Trees built with DNA morphology are both models of what we think happened. Small changes in assumptions, right? So small changes in assumptions on these phylogenetic trees can change the whole tree. If you take the mutation rate into consideration, it'll change a tree. If you consider gene flow, it'll change a tree. All of these things can produce, and then you can keep going on down the line. Horizontal gene transfer, introgression. We finna get into all of that, right? Taxonomy reflects human categorization. Nature doesn't label species. We do. So these categorizations reflect what humans are doing, not necessarily what nature is doing, right? We are projecting onto nature. And it could just be one continuum of the same thing. And we are doing the separations. You need to understand that, right? You really got to understand that nature is not telling us. We are making the claims and saying, well, we're going to cut this line here and say this is different. We're going to cut this line here and say this is different. We're going to cut this line here and say this is different. Nature isn't telling us this. We are projecting onto nature, right? And we can do that, but we have to substantiate it. And right now, we don't have a way to substantiate it. We're just doing lookership. Our categories are often shaped by historical biases, cultural assumptions, practical limitations of the data, like race and human. Species categories don't always match biological realities, especially across evolutionary time. I just gave you an example, right? You got you got DNA from two different Neanderthals, but the bones look totally different. So it ain't matching the visual that we have. And then you had the morphological concept that you could put it in a different category and call it a different species, right? So this is another part of the article that we just read, and I'm just trying to break down each individual piece of the article. Since then, I've continued to document the human fossil record with detailed descriptions and lots of photographs. And the more specimens I studied, the more I realized that most of these species designations don't make sense. If hominin fossils were treated the same way as non-human primates, specimens currently lumped into the same group would be allocated to different ones. We need to go back to taxonomics basics. Hello, that's why we're here right now, right? This is a biologist telling you that it don't make sense for some of the things, right? He's saying that hominids and Homo sapiens are supposed to be related, but we have two different criteria. But who come up with the criteria and why? Right? That's the question. Inconsistency in classification standards. That's what we're talking about, the inconsistency in taxonomy, right? When comparing hominins to non-primates, the bar for defining new specimens in humans is often higher and more arbitrary, right? More random. Arbitrary is like randomness. Examples, fossils with minor differences are lumped into Homo erectus. Meanwhile, in gorillas or monkeys, such differences might justify separate species. Are you seeing what we're doing here, right? So within humans, right, the minor differences in the Homo genus is all lumped into the same thing. But whenever we look at monkeys, gorillas, and apes, we take these minor differences and say they're whole different species. Who made that so? Right? Says who? Right? And why? They just made it up. Right? So we have a double standard. Human fossils are often forced into broad categories that wouldn't be tolerated in other mammalian taxonomy. Right? That's the point. Let's keep it moving. Too much lumping and not enough splitting. Paleoanthropologists often lump diverse fossils into a few well-known categories, such as Homo habiligansis, Homo erectus, to maintain narrative simplicity, right? They're trying to stick to this narrative, even though we have this variety, right? And sometimes you don't know what, and you don't want to just keep making new classifications, you know what I'm saying? Because you don't really know. As you come down in history, people know that these are necessarily might not be new stuff, so they just lumping them into old stuff and have variation. But if we apply the same criteria used for living primates, we'd likely have far more hominin specimens each defined. This is just to reinforce the last slide, really, right? Also, we got to look at historical baggage and taxonomy, right? Much of human taxonomy was built during the time of ethnocentrism, colonial influence. Figures like Leonidas, Blumenbach brought racial bias into the classification system. Later, scientists often frame Homo sapiens as the ideal and other hominids as primitive steps toward it, right? So we got this hierarchical, right? When we say we modern humans and these other people is archaic, you are implying that these people are not as smart, but we don't necessarily know that because we have finding nowadays of these archaic humans having burial practices, different tools, dealing with fire, having a lot. You know what I'm saying? So there's an implied hierarchical structure which implies a bias that we don't even know that exists or not, right? When we call these things primitive or archaic, right? These narratives shape what we call a species versus a variation based on value judgment, not biology, right? Did you know that less than 1% of the fossils we have concerning human evolution have we extracted DNA from? So DNA is not even a big part when you talk about the evolution of humans. Out of all the fossils that we have, we've only extracted less than 1% of DNA from these fossils. So you know we don't have no DNA analysis of the record. So what is it? It's what I'm telling you, right? But we often talk like we know about these things because genetics. No, we don't. It's less than 1%. Look it up. I'm trying to tell you. And then we have epigenetics, which is a whole other beast, right? Epigenetics is when it's going to get even more complicated, right? Do you know about epigenetics? What is epigenetics, right? Epigenetics refers to heritable changes in gene expressions that do not involve changes to the DNA sequence itself. These changes are often triggered by environmental factors such as diet, stress, temperature, and toxins, and can be passed on to offspring at least temporarily. So you telling me we can have changes that occur in organisms, humans included, that don't change your DNA, but will change you physically? How does that fit into the picture, right? So this bogs down genetics, right? And how we're using it to classify, because you can have changes that's expressed, but it won't show if you're just looking at the DNA. Epigenetics refers to heritable changes in gene expression that do not involve changes to the DNA sequence itself. These changes are often triggered by environmental factors and can be passed to the offspring, at least temporarily. That bogs it down even more. Let's continue. The problem of morphological plasticity, that's another word for epigenetics. Some species, especially early hominins, show wide variety in body size, skull shape, and limb proportions. So when you hear people talking about, oh, they know the classification because limb proportions, which they are basically measuring the fossils. They classify them by how long, thick, bone density they are, stuff like that, right? They saying limb proportions is how they classify them. But when you talk about homonyms, it don't work because there's so much variation in the limb proportions. You can't really classify them by that. It's too much diversity. I mean, it's too much variation. That raises the question, are we seeing one species with high variability, or are we mislabeling multiple species as one? That's the question. Without genetic data, we can't easily tell, so we default to assumptions, many of which are questionable. Epigenetics cause it up even more. Phenotypic plasticity without genetic change, right? Epigenetic changes can cause major physical or behavioral differences in organisms exposed to different environments. Taxonomists may mistakenly classify epigenetically altered individuals as different species because they look or act different, right? Example, check this out. Identical clones of genetically the same plant can grow into very different forms depending on environmental conditions, purely due to epigenetic influence. Let me say that again, right? You can have clones, right? Two things that are identical, right? Put them in different environments and they will grow completely different, right? Have completely different morphological features. Same thing in humans. Look at you. Look at me. Look at all the humans that exist, and we are 99.9 the same, but look different. Look at the pygmy people and look at European people. If you dug up their fossils 10,000 years from now, you would think that they were separate species. Look at the Aboriginal and look at the Chinaman. If you dug them people up 10,000 years from now, you would think that they were different species, right? Just by the looks. That's what we tend to do. Reversible and transient changes. Unlike DNA mutations, epigenetics changes are often reversible and may not persist across many generations. Think of how that affects the classification system, right? Because these things may not even be permanent. No, may not. They are often reversible and may not persist across generations. So you find a fossil with an epigenetic mutation, and then you may find another fossil right next to it that's the same thing but have a morphological variation, and you think that it's different, but it's really the same. How many times I got to say it? This makes it hard to determine whether observed traits are stable evolutionary changes, supporting a species boundary, or temporary adaptations. Example, some fish change sex based on environmental conditions via epigenetic regulation, but still are the same species, right? Because we're talking about organisms, right? And humans are organisms. So we got to try to find, a consistent definition, right? If it's all these species and we call them all species, but we don't have no dang consistent way of classifying them, right? Masking or mimicking. Masking, is it masking? Oh, I can't even see that. Let me try to blow this up so I can see that. Yeah, masking or mimicking genetic differences. Epigenetics can either hide genetic differences or mimic them, which interferes with molecular methods used to identify species. DNA-based methods like mitochondrial barcoding might miss these subtler expressions-based differences. So even if we have it, DNA ain't the whole story because it can't identify the epigenetic changes. They don't know if they're looking at that or not, right? Man, Epigenetics shows that genotype and phenotype and organism traits are shaped not only by its genes, but also how these genes are turned off or on in response to environment. This blurs lines taxonomists use to define species by. So epigenetic challenges the assumptions that visible or behavioral differences always reflect genetic divergence, making species classification even more difficult, right? Now let's talk about introgression, right? People be messing this up. I'm gonna try not to mess it up, right? Introgression, the transfer of genetic material from one species into the gene pool of another through the hybridization and backcrossing, right? Meaning you have species A mates with a different species, so-called different species B, and then they have the offspring C. But then what does the offspring C do? It has to then go back and populate with one of the mom's populations or the dad's populations. And then what does D? And this bogs down the lines, right? Because you have, two species, the distinct species that already can mate, right? So that's clouds it. And then you have a mix, which is the hybrid, and then the hybrid goes back and mixes into the other population. Because when you're talking about the first ones of the offspring, they don't have nothing like them to even mate with. So they got to go and mix with either the A or the B, right? When you're talking about the first, right? Let's go to the next one. So this is the definition, another definition of introgression. Two species interbreed, producing a hybrid. That hybrid mates back with one of the parent species. Over generation, genes from one species leak into the other, even though the two remain separate species overall. Man, clouds the water even more. This is another way that you can get so-called different species whenever we look at them genetically. The genetic bottleneck, right? When you have a founder population, which is the yellow, because I guess you guys can't see my cursor. I don't know if you can or not. Yeah, you can. So you have like the foundation population, the founder population, which is in the yellow, right? You have the African, and then they leave. Boom. One, not all of them. You have a breakaway population that leaves Africa. Boom. Then they go up to like Europe and they stay for like 10,000 years. And then they have a genetic mutation which makes them distinct from the founding population. But you know what? The founding population has been home 10,000 years and they didn't mutate it again, right? And then you get a second migration out of Africa. Boom. And then that second migration mixed with the first migration. Boom. And then they make some different shit, and then that different shit go back and mix with the founding population, and then you got something else. Supposedly, right? Are they all the same variations of the same thing? That is the question that's being asked. What are these taxonomic lines? Are they in our minds? Are they really natural distinctions? Right? I already read that. Oh, I'm going backwards, right? Let's go up. Now we really got to deal with these terms non-African and non-human, right? People be messing this up all the time. Non-African and non-human DNA and acting like it's something other. It ain't nothing other. These are just naming conventions, right? These are just names. These are labels, right? Don't necessarily mean it's other, but they got to name it something, right? Non-African genetic variants. Genetic variations outside of Africa is largely a subset of the diversity found within Africa, reflecting the out of Africa migration and the subsequent founder effects. That's what we just got through talking about. So these non-African genetic variants are just a subset of what's already in Africa, right? But we call it non-African, but it's a marker in how we identify this so-called other, right? Outside of Africa, genetic variation outside of Africa is largely a subset of the diversity found within Africa, reflecting the out of Africa migration and subsequent founder effects. This is just a reiteration of the last one, right? So let's talk about what it is and what it's not. Non-African DNA and non-human DNA, right? Non-African DNA. DNA that originates from ancient human populations outside of Africa, especially from those that mix with the anatomically modern humans, Homo sapien, after migrating out of Africa. Even this definition can be misleading, right? Because it says DNA that originates from ancient human populations outside of Africa. What do they mean by that? It's DNA that mutated outside of the African continent, right? But all of it originated from Africa, right? But you just have a variant that didn't mutate on the continent, right? So let's not confuse that, right? So let's say what it's not. It's not a racial term. It's not implication of separation or inferiority. That's what non-African DNA don't mean, right? Non-human DNA. DNA that comes from organisms other than Homo sapiens, right? That don't mean it's not human, right? Because you have other that's in the Homo family, right, that are still relatives, often referring to the admixture with archaic humans such as Neanderthals or Denisovans, right? What is not non-human DNA? Means someone is less than human. It don't mean that. These are just conventions. Remember, it's just labels. And sexual mixing was a negative event. Don't necessarily mean that. Even though you might get some medical disadvantages, but you might get some climate, some equatorial, some ecological advantages at the same time. So it just depends on where you at and other factors. So let's break it down even more. So using these terms can confuse the layperson to believe that people with non-African DNA don't descend from the so-called African, or that non-human DNA in terms of human ancestry refers to something other than archaic humans. Let's give a little more context. Non-human DNA and human genomes. It is scientifically accurate that modern humans have inherited small segments of DNA from archaic human species, such as Neanderthals or Denisovans, due to interbreeding. And let's not forget, it don't necessarily have to be interbreeding. That's not a fact. It could just be that's just who we are, due to interbreeding tens of thousands of years ago. These segments are often colloquially described as non-human or archaic DNA, but it is important to clarify that Neanderthals and Denisovans are human relatives, not completely non-human entities, right? The phrase non-human DNA could be misleading if interpreted outside of this specific scientific context. Let's do this. Non-African DNA, right? In population genetics, non-African sometimes refers to genetic lineages over variants more commonly found outside of Africa, often due to historical migration patterns. All modern humans have common ancestry originating in Africa. The presence of so-called non-African DNA segments like Neanderthal DNA outside Africa reflects this terminology does not DNA. Let's go back. The presence of so-called non-African DNA segments like Neanderthal DNA outside of Africa reflects the historical interbreeding events after humans migrated out of Africa. This terminology does not imply that any population is not descended from African ancestors, but rather highlights differences in archaic admixture due to migration and interbreeding. Let's get that understood. We can have this conversation. This is the Homo family. All these people are related, right? At least that's what we are led to believe, right? Similar genetics, similar morphology, right? So this is a graph, and we're comparing the genetic similarity between modern humans and archaic hominins, right? The bottom graph, modern humans versus modern Homo sapiens versus modern humans. We are 99.9% the same. You know, modern humans are Homo sapiens, pretty much. Modern humans versus Neanderthals. We are 99.7% the same. That is only a 0.3% difference, not a 3% difference, a 0.3% difference genetically. How much difference can that be in reality? Modern humans versus Denisovans. We are 99.6% the same. That is a 0.4 difference. How much can 0.4 difference be? Biologically speaking, even if your morphology is different, right? Modern humans and chimpanzees are 98.8% the same. That's pretty much a 2% difference. That's when you step up to whole percentages, right? And that's still a lot the same, a whole lot. So, I mean, that's pretty much where I want to land my plane right there, man. Because people mess that up a lot. Often think that we're talking about different things. Now people mess. This is another thing that people this is another thing that people mess up, right? So people will often say, "Where's the humanity?" Saying that if humans come from chimpanzees, then there should be a humanity in the middle, right? Because they just thinking about breeding. But breeding is not the only way that new things can come about. This is a visual example of how new things can come about, so-called new things, right? Because they could be the same thing, but just different variation. That's coming from due diligence. How do new species evolve? Species, number one, species live in a certain area, right? And then these two species split off. A group of this species split off, right? And they become separated from long periods of time, right? And then number three, these same populations over millions of years can have more mutations along the line and then turn into different things. I just messed that up. So I'm gonna say it again. You can have one population of people, right? And then a group of them split off. And then they split off and be separated for long periods of time. But these two are evolving together. So whenever you come 1 million years later, 10,000 years later, these two things are genetically distinct. And that's how you can have two different things, seemingly two different things genetically, and it ain't necessarily got nothing to do with interbreeding, right? It's just genetic mutation through random mutation or through environmental changes, right? You can change like that also. People always leave that out, right? And we got to talk about this. People mess this up and be like, oh, we different species because we can't have valuable offspring. Like the horse and the donkey come together and make the mule. But the mule is not valuable offspring because it cannot reproduce. But what if I told you that some mules can reproduce, right? It's not overall. So that even makes it murky because whenever we talk about these things, there are exceptions to the rule, and the exceptions don't become the standard, but it exists, and we just need to talk about it, right? Genetic diversity. Whenever we look at these types of people, right, we don't look at these as different species. This is just genetic diversity. So the question is, whenever we're looking back into the past and we see these morphological differences, we can also say that's just genetic diversity too, genetic variation, right? Variability, because we don't think black people and white people are necessarily different species. It's just variability of the genetics, right? We look at the crow and the hooded crow come together and they can make the hybrids, right? How this another way how new things emerge. So I just want to leave you guys on that note. You know what I'm talking about? So yeah, man. So I just really wanted to make that understood that I don't think we really have a good grasp on how we're looking at these things, and things are not so different after all. And also, I think we need to take another deep look at the models, right, that we use to make these discernments of distinct species. It's not necessarily so. And I just gave you a million reasons why these lines are blurred, right? So we just got to take these things into consideration, right? We're dealing with these things. And if you guys want to come in the building, there go Pan African James right there. What up with it, broski? What's happening, my guy?
You can hear me?
Yeah, I can hear you.
What's going on?
Man, just building. What you think?
I don't know. I'm kind of confused.
I'm listening.
Because I could have swore we just had a conversation. We was in agreement.
So what do we disagree with now?
I don't know. You saying that it ain't no such thing as speciation. It kind of sound like to me.
I never said that.
Okay. Well, then maybe I need to break then. Because that's kind of like what it kind of sound like. Because some kind of way, Sadiq is over there cheerleading like you over here saying something different than what we just talked about on the phone.
Well, I don't know what you and Sadiq is talking about, so I can't say.
You're right. Well, okay. Well, so we ain't one. We still on the same page.
Yeah, I believe so. If you want to talk about what I said specifically, right, we can talk about what I said specifically. But I never said that speciation isn't a thing. My question is, how do we determine different species? Right? What is the method? What's the criteria? That's what is in question. I'm not saying that they necessarily don't exist.
Let me ask you this. Okay, so genetics cause different things that happen within a species, right?
True.
So do you know that a bonobo and a chimpanzee is classified in taxonomy as a different species?
Yes.
Do you know what they look like?
Yeah, I've seen them before. I can't say it off the top of my head. What's the point?
They look very, very, very similar, right?
Correct.
You got to pull up a bonobo and a chimpanzee and put them side by side.
Well, make your point first, because we may not have to do that. What's the point that you're trying to make?
They classified as a different species based on genetic differences that they have. Guess what their genetic difference is? 99.6%. That's what makes them different. 99.6% difference in genetics makes them a different species. So same thing with humans. That's our closest relative. So if we 99.9% the same as Homo sapiens, then when Svante Pavo found the Neanderthal DNA was off in archaic humans outside of Africa. That's what changed the taxonomy of it from a scientific perspective, not just from a guessing perspective or lookership or archaeology, just using a certain skull and saying that this is what it is. So the skull that he used that they already had named Neanderthal, they got DNA from it, and they found that DNA was different from human DNA. I mean, from Homo sapien DNA. Now, if you saying that that's not true, then I don't know, but that's what they saying that happened.
So I'm saying you are right. That's how they doing it, but I'm saying that they can't substantiate just because you have a genetic difference. What I'm telling you is sometimes you can have a genetic difference and still be able to breed and have viable offspring. So how different are you? All right, just let me finish what I'm saying, right? So what you're saying is true, but I'm questioning that method because, like you said, you can have two things that look identical and have different genetics, and they will say these are two different things. But you can also have two things that look completely different and have the same DNA, and they'll say that these things are different.
What about, let me use another example then. What about the polar bear and the grizzly bear? They can procreate with each other. You know that, right?
So my question is, does that mean that they are the same or they are different?
They're different based on phenotypical features. One of them is totally white, and one of them is brown, and he's bigger, And no, I would take that back. Polar bears are bigger actually than grizzly bears, but they have different phenotypical features. They're adapted for their environment to be able to survive in the environment that they're in. So they're different species in taxonomy. It's really that simple. It's not really nothing to really be tripping on because that's what humans do. We taxonomize things based on different phenotypical features, even though they may be close in genetic makeup. We just put them in the same. We just put them in the same family, and then say based on the different features that this one's a red. What we say, one of them's a blue jay, and one of them's a red. A red canary cardinal. You know what I mean? So this is what humans do.
Yeah, but I agree with you. I agree with you.
I wouldn't say a falcon is a bald eagle. You know.
I mean, that's what's in question, right? Because what I'm trying to explain to you, James, is that things can look completely different and be the same, right? Because we can take examples of like the pygmy, right, and the European, right? They look like two different things, but they can mate. We know they are the same, but they look completely different, right? You can have things that are close genetically, right, that look absolutely the same, right? And they can be the same thing or they can be different. You know what I'm saying? So you can have things that have two different types of DNA and still be able to mate, like Denisovans.
But they name that it got a name for it. It's called hybridization. That's just what humans did. They just say, okay, this is how we identify hybridization. That's it.
Right. That's what it's called. But my thing is, the point that I'm trying to make is how different in reality is it? This can just be genetic variation, meaning genes just expression in different forms, but not necessarily different, right? I'm just saying it's variety, not a whole different species, because species implies different substantially, right? But I'm just saying that it could possibly be just genetic variation and just superficial differences and not, necessarily substantially a different thing. Does that make sense?
Yeah, you can do a lot of things, bro. Everybody can do what they want to do, but in the scientific realm, they got certain things that they have already put in stone, bro. Like it ain't no need in fighting certain, like us being taxonomized as Africans or something. Like what we want to say, we not Africans because then we just want to change our name.
Yeah, I think we could question the. I think
we can do that all day. You know what I mean?
And I think not me, because you're talking about how what scientists do. I just want to bring this up, and I want to see what you think about this. Right? I want to ask you what you think about this. Right?
But you get what I'm saying about the polar bear and the grizzly bear, right?
Absolutely. So what do you think about this? This is a paleoanthropologist. He's also an archaeologist. He's also a biologist. So hold on, let me get it right. So he got a bachelor's from Columbia. He got a doctorate from Columbia. Research, education. I'm trying to pull it up. Okay. Jeffrey Salch is a physical anthropologist whose research and teachings cover three major areas. So he's a physical anthropologist, right?
So what? And
he's got a doctorate.
Between that and a paleoanthropologist,
I don't know. So here's what he's saying.
That's another text. Here's what he's saying in this article. Go ahead.
No, that's profession. That ain't got nothing to do with taxonomy. But this is what he's trying to say.
But I'm saying, but that's not. But
let me read this article right quick. But that didn't have nothing to do with taxonomy.
Okay, what did you say it was again? I look it up.
I'm fancy.
The archaeologist.
What do you do? So everything that's been called Homo sapiens isn't.
Is he an archaeologist? Yes. Is that what you're saying?
Yes. He
okay,
is an anthropologist. An anthropologist.
Okay, that's what I would need to know. Go ahead. Mm-hmm. Okay.
So he's an anthropologist, right? And he does archaeology, right? And this is what he's saying. Everything that's been called Homo sapien isn't. That's his premise. So whenever you come and say things have been set in stone, this dude is challenging that notion that things aren't set in stone. He says, in my opinion, far too many species have been lumped together into this one taxonomic category. The truth of the human story is far more complicated, with more species and even more genera than have been named, and more dead ends on branches of the human family tree that have been recognized. As an evolutionary biologist, right? So he's also an evolutionary biologist, right? I've always been interested in the theory and practice of how one defines a species and tries to figure out its evolutionary relationships. I came to understand that this process is only ever hypothetical, never provable. I didn't say this. Right. So it's not set in stone. He's saying it's hypothetical. This is coming from the evolutionary biologist, the anthropologist, right? He says he began in the 1970s studying early mammals, then lemurs, and then prosimians, then apes. I stayed away from hominids at first. There was too much storytelling and not enough evidence for my taste. But my frustration with how the human fossil record was interpreted, right, pushed me to this arena in 1997. My first goal was to put together an encyclopedia of how many human fossils I could get permission to study. This led to 3 volumes. The last published in 2005. So he got 3 volumes worth of fossils he done studied himself, right? An encyclopedia that he's published himself. Since then, I've continued to document the human fossil record with detailed description and lots of photographs. And the more specimens I study, the more I realize most of the species designations don't make sense. Huh? If hominin fossils were treated the same way as non-human primates, specimens currently lumped into the same groups will be allocated to different ones. We need to go back to taxonomic basics.
Hold up, dude. Can I ask you a question before you keep going?
Yes, sir. Yep.
So is he saying that that the DNA that they found out in Homo sapiens sapiens at 99.9% not identifiable? Or is he saying that the DNA that they found off into what they're labeling as Homo sapiens? Hold on, I'm asking the question. Or is he saying that the DNA that they found off in Homo Neanderthal not identifiable? I'm trying to figure out what's going on.
Let me answer the question, because he hasn't even spoken to how he come to his conclusions yet. He's given his premise, so he hasn't even got to DNA. He's finna state why, so he hasn't said nothing about DNA yet. But he will.
But I know. I was just
let me finish. So this is what I ask you, James. Do you know that there's only been less than 1% of DNA extracted from the human fossil record? Did you know that?
Yeah, but what does that have to do from a genetic level? I'm not even talking about what the fossil records say. I'm talking about have they extracted the human genome to 99.9%? Yes or no?
We looking at different the fossil record. That's what he's talking about. We're talking about anthropology and taxonomy.
I'm not looking at fossils. I'm talking about genetics right now. Well, I guess James, you don't want to talk about that.
James, we're not talking about what you're talking about. We're talking about what the paleoanthropologist is talking about, right? What the anthropologist is talking about, right? So let's stay on the same page. Let's talk about what he's talking about, right? Having studied so many human fossils is both a blessing and a curse. The blessing is that I can apply my theoretical comparative background to virtually the entire human fossil record. The curse, I don't always see eye to eye with other paleoanthropologists who often focus on 1 or 2 species, a geographical area, or a period of time. So he said that even amongst the paleontologists, they don't agree, and which they don't. We all know that they don't agree because there is no consensus on the matter.
But hold on, dude. I heard you read this earlier, so what I'm saying is you really ain't got to keep reading it again. Didn't you just read this earlier?
Well, you asking me about.
No, I'm not asking you to continue reading. I'm trying to ask.
Nobody said you asked me about the continue reading, but I'm answering the question that you asked because the statement that you said, because you said these things are set in stone, and I'm showing you a biologist that's saying that it's not set in stone. Right?
But that's just what one of them says, and then another one says that it is. So what do we do?
Show me one to say that it is, then, James, because you just said that.
Man, Svante Prabhu won a Nobel Peace Prize for finding Neanderthal DNA. So what you think he lying?
James, that has nothing to do to say with the taxonomic categories are set in stone. That's 2 different things.
No, but the fossils that he used were these same fossils that he's talking about. The ones
Yes.
that they named the Neanderthal before he even studied the DNA.
Exactly.
They named it based on the cave.
Exactly. And we're talking
Right, so
about how
that's
it's
what they named it.
classified. But we're
Yeah,
not
they
talking
named it
about the
based
name.
on the
We're
cave
talking about the classification on how it became classified. Do you
because
know
they
how it
found it in
became
the
classified?
cave,
Do what?
right? Is it not because they found it in the cave in the Neanderthal Valley?
That's how it became named,
Okay.
not classified, because you got to know the method of how they classified it. And that is what that's what's in dispute right now.
Okay,
right?
now stop, dude. Before he classified it, they just called it Neanderthal based on the fossil record. The DNA that he got out of there is what verified that they were the different species. I didn't make this up. Am I making that up? You want me to put a Savante Pablo?
You can, but slow down. Let's just have a conversation. So let me tell you what this guy said, right? He said that you can have a Neanderthal DNA in one fossil, right, that looks one way. And then you can have Neanderthal DNA in another fossil that the morphology and the phenotypes look completely different, but genetically they're the same. So this is what bogs down the issue because you have two conflicting criteria. You have the phenotypical morphological criteria that they lumping together, and now they have a DNA category to what they lump together, and these things clash at times, right? These things be clashing. That's the point that he's making, right? So this is not against. We are just pointing out the weaknesses on the classification scales.
Yeah, I definitely agree that taxonomy can be either way, bro. Because they named the Denisovan based on the fucking cave. So that's just the taxonomical. But what we're talking about is from a genetic level, how they identified and did say, like they thought that the Denisovan cave was all Neanderthal until they found that damn bone. They said, oh, that's not even in a Neanderthal, based on a genetic level. That was what made them reclassify. It wasn't based on no lookership of or what they thought. Matter of fact, they only found the damn bone, a finger bone. They don't even have a skull, a fossil of it. So how was they able to identify that it was a different species from Neanderthal based on their finger, on that pink finger bone? How was they able to do that?
I'm trying to explain it to you.
Okay, let me mute out.
So they have the Neanderthal sequence, and if it's not the same, they make the discernment, right? That's how they make the distinction, and that's what they saying is different. But here's what I want you to hear, James. You can have genetically variants, and they may not be different species, is the point. They don't know that these things are different species. According to the article that I just wrote, this man said that you can have genetic variations could just be a common thing, right? Because we don't have enough fossils that we have extracted DNA from to make that determinant. But from now, we just have these placeholders. We say Denisovan is one thing, Neanderthal is another thing, right? But it don't necessarily make it true because they can't substantiate it. They can say we're looking at these different genetic variations, but they only have less than 1% of DNA from the whole entire fossil record. So you can't make swooping conclusions like that. They only have less than 1% of genetic DNA that they even looking at to compare fossils. So yes, they are saying that they're different, but they are not necessarily the same, and it's not substantiated.
So they don't have the full genome of Neanderthals?
I wish you would, whenever you question
we're talking about a genetic level. You saying they don't have the full genetic you rewind back what you just said. You said they don't.
That's what I'm saying.
Okay,
James, how can you challenge me whenever you can't say what I said? Because whenever you try to repeat what I say, you change it.
Okay, go ahead. So I won't change. Say what you just said again. Then.
I said they have less than 1% DNA extracted from the complete fossil record. Less than 1% of DNA has been used to determine what things are in the fossil record.
Well, we know that they don't have DNA from something that's further back, like 1 million years old, because they said they can't get DNA from something that old. So you would be absolutely correct in that sense. But we're talking about what they do have, not what they don't.
Correct.
Why would you focus on what they don't have when we're talking about what they do have? They
Because
do
you
have
got-
the full, hold on. They do have the
honest.
complete genome of Neanderthal, and it's separate from Homo sapiens sapiens. That's a fact. They do have the complete genome of Denisovan based on the damn pinky bone, and it's different from Neanderthal. Matter of fact, they got a 50-50 Neanderthal Denisovan breeding. It's called Denny. You can go look it up. And it's just based on a genetic level, bro. So I don't know. So I'm confused as what you just talking about maybe fossils or something like that. But look up Denny when you get time, bro. That's a 50-50 procreating a breeding between Neanderthal and Denisovan. It's called Denny. So there's your evidence right there.
Right.
It's just
So
speciation, though.
Let
I
me
don't
tell
know.
you what he said.
Like a lion ain't a tiger. But they come from they both come from the feline family.
So let me tell you what he said about DNA. First of all, DNA has only been successfully extracted from a handful of fossils, right? We got thousands of fossils, right? Probably more than thousands, maybe tens of thousands, right? I could be stretching, but I know it's less than 1% that we have extracted DNA from, including some Neanderthals. Okay, so let's go down. DNA analysis are missing most of the pieces of the puzzle. So, because what we have to do is, yes, they have a Neanderthal, but now you have to compare. What do you have to compare it with? When you talk about the fossil record, we don't have nothing to compare it to. And there are circular arguments, right? DNA is defined as, let's say, Neanderthal, because the fossil was identified as such. And then it is used to identify other fossils as Neanderthal, even if they don't look like Neanderthal, right? So while certain similarities between our DNA and Neanderthal DNA has been interpreted as evidence of two species interbreeding, these similarities could just be run-of-the-mill features of the genome, common to many species. That's what I'm trying to tell you. So you acting like you know that these things are distinct, but the biological anthropologist is saying that that may not be the case, and this thing is not set in stone. I'm trying to tell you that these people build a narrative. That is the hypothesis. What we do have is what you said, but how they come to that conclusion is not substantiated, right? Because here you have somebody who's in the field that is telling you that it could be, it don't have to be through relation, right? That you can have two things that have the same DNA, exact same DNA, and look morphologically different. That's the point I'm trying to get to you.
But I'm not talking about lookership. I'm talking about on a genetic level.
I just explained to you on a genetic level. They could be the same and be different, or they can be different and be the same.
Well, how is it possible that Neanderthals got different stuff in them that humans don't got then? If it's the same. Like the HERT2 gene, for example.
So
but humans don't have that. Homo sapiens, I mean.
Don't you know that you and different European people have different genes? Me and you may have different genes, but we are still 99.9% the same. So whenever you focus on the differences, it makes it seem like it's something completely different, and it may not be. Bro,
no, I'm just talking about what science said they identified.
I'm talking about. I just tried to explain it to you.
Neanderthals. That's what I'm saying. They identified the HERT2 gene. They identified the OAC2 gene. They said that was exclusively in Neanderthal. They said that Neanderthals lacked the FOXP2 gene that was associated with speech in humans. I can pull all this up. So I don't understand.
You know what? Also,
that this is not what I'm telling you ain't true.
Oh no, you're not speaking to what I'm saying. You're just talking about what you want to talk about. But this is what I will say. They also used to classify Neanderthals. They also used to classify Neanderthal as a different species. Now they're trying to say that Neanderthal is not a different species since we found out that they can have viable offspring with humans. And now we also know that you have different. They're not saying that?
No.
Well,
they're saying based on them finding them that they found hybridization, but they still are a different species of Homo. Homo habiligans is a different species than Homo sapien. It's just taxonomy.
No. So
Yeah.
let's
Homo
just pull it up.
Neanderthal is not Homo sapien.
Yeah, but
genetically.
are they different? Are they different species?
Yes.
Okay.
Based on genetics.
All right. So let's just do this.
Not based on that one guy. I'm talking about on the consensus of science, not him. He's just one person in this field of science. If you want to use a minimalization of type of analysis here, that's one person. Look up what other scientists think.
Okay.
The consensus. Do consensus say the Neanderthals are the same species as modern humans or Homo sapien? But you should know that Homo neanderthalis is not Homo sapien.
Okay. So let's do this. Let's do this. Oh, here we go right here. Okay, so are Homo sapiens and Neanderthal the same species, right? We're talking about what science is saying right now, right? I said no, you said yeah. While generally classified as distinct species, with Neanderthals being Homo neanderthalis and modern humans being Homo sapiens, the relationship between Neanderthals and modern humans is complex and debated. Some scientists argue that they could be classified as the same species, what I just said, right? And other Homo sapien Neanderthalis and Homo sapiens are simply merging them into Homo sapiens, while others maintain they are separate species. The key point of contention revolves around their ability to interbreed and produce fertile offspring, which is a definition, which is a defining characteristic of species according to the biological species concept. So you do have new scientists. He said this is a debate. That's an ongoing debate if they are distinct or not. That's what I said.
But
that's exactly what I said.
Put in the consensus? I don't think that's in the title. What is the consensus? Goodness. What do they think? What is the consensus? That prompting is that shit is deadly. You can make shit say what you want to do. I know that.
It was a general. I just said, are they the same species or not?
I'm just saying, what is the consensus in
science? but you try to say the way that I prompted. You tried to say.
I'm not insinuating. I'm just letting you know that that's how it works.
I know. Said,
not just you. Everybody can do that. Anybody can do it. Me too. I can make that shit say what I wanted to.
So
to a certain degree.
So this was the let's go through it. It says no. Homo sapiens and Neanderthals are generally considered separate, though closely related species. While they interbred and share some DNA, the consensus among scientists is that they are distinct branches of human family tree, with Neanderthals classified as Homo neanderthalis. Here's why. Yeah, but I'm telling you, the new science is trying to say that they may not be. We're talking about the old moving into the new. I agree with you because that's what I literally said. I said that the old notion. Let me finish saying what I'm saying. Let me finish saying what I'm saying. I'm saying the old notion is that Neanderthals and Homo sapiens were classified, but now with genetics and the new science that's available, they saying that they might be the same species, right? That's what science is saying.
Do you know that before 2010, that's what they were saying? They were saying that we was all the same. They said that we was all the same species before 2010. That's what the consensus was. Until they found Neanderthal integration in all non-Africans, they thought that everybody was just 99.9% the same, with only 1% accounting for recombination, and based on environment and other shit. So I didn't add this in there. Science did that. And you saying the science is wrong, like they didn't find Neanderthal DNA. That's kind of like what you're saying, dude. Okay? I'm just letting you know.
That's absolutely not. I just read an article talking about him finding Neanderthal
DNA. And we went to find out what the consensus said too, dude. I'm just saying.
But how am I saying that they didn't find Neanderthal DNA, James? You just made that shit up. I literally read an article. No, because
what I'm saying is
will you stop talking over me, though, bro? Don't make me do you. I'm gonna let you talk. James, stop talking over me. I'm gonna let you talk, but let me talk and let me finish my words. so that we're not going to talk over each other, right? So
Okay.
I literally read the article of what the scientists said. I didn't say nothing, and I reread it, and then you're going to ask me, "Are you trying to say this?" I said, "No, he is saying this, right?" And then
Okay.
you
Okay. Well,
ask me,
that's
"What
cool
is the
then.
consensus?" James, can you let me finish saying what I'm saying? I'm gonna let you talk, and then you ask me, "What does the consensus say?" And it says the consensus is being challenged. Let's just keep on reading, right? Let's just keep reading. All right. How do Homo sapiens and Neanderthals differ? The physical traits of Homo sapiens are rounded, more balanced. Let's see, biological concept, and it does depend on which concept you are using too. Let's see, life science. So this is
Just do it on a
2024.
genetic level. Would that be okay?
Let's see what
How do they
life
differ on a
science
genetic level?
says. So scientists have been volleying the question. Let me do what I'm doing right now, James, and then I'll let you say whatever you want to say. Are Neanderthals and Homo sapiens the same species? Scientists have been volleying the question back and forth for more than a century. This is 2024 from Live Science, right? They've been going back and forth on this. What I said was that's an old notion. The new notion may not be that. Neanderthals was disappeared from the archaeological record roughly around 40,000 years ago, have long been considered our closest evolutionary relatives. But almost since the first discovery of Neanderthal remains in the 1800s, scientists have been arguing over whether Neanderthals constitute their own species or are they simply a subset of their own species, Homo sapiens, that has gone extinct. So what does science say in particular? What does genetic evidence, which didn't exist back when many early hominins were first discovered, show? The question of whether Neanderthals can be considered the same species as modern humans is complicated by our understanding of what a species is. The whole point of my presentation. A physical anthropologist who we was just reading, who ain't this, and professor emeritus of the University of Pittsburgh told Live Science the most common definition, called the biological concept, describes a species as a group of individuals that can interbreed in nature and reproduce valuable offspring. But even today, several odd hybrids poke holes in this definition. It's poking holes in that definition. Horses and donkeys can breed. I brought that up, but mules, but the mules that give birth to are sterile, and so the two are considered two different species, Schwartz said. But other combinations do produce valuable offspring. Like I said, these include the liger and the tiger and the buffalo, across the crow, the bison. For a long time, scientists didn't know whether Neanderthals and modern humans interbred. So this definition wasn't particularly enlightening. Instead, early assessments were made based on Neanderthal anatomy, how they look. We talk about lookership. I said that, which is different from Homo sapiens. Which is different from Homo sapien, that specialists can often distinguish bones from two groups. Neanderthals had a long lower skull with a bonier forehead and a less pronounced chin than Homo sapiens, for example, and their bodies were stockier. Because of this, 1864 Neanderthals was classified as their own species, Homo neanderthalis, but more early human relatives were discovered, such as Homo erectus, Homo habiligandus. Their relationship to one another became increasingly complex. Compared with other species, Neanderthals seem much more human, Schwartz said. Recent research suggests that both groups had similar auditory and vocal abilities, and controversial finds hint that Neanderthals may have had buried the dead and made jewelry and art. In 1962, a group of anthropologists, geneticists, behaviorists met in Australia to draft and vote on evolutionary history of human relatives based on the specimens that have been discovered at the time. Their resulting manuscript, called Classification of Human Evolution, placed Neanderthal under Homo sapiens as a subspecies, or
can you start reading real quick?
Homo sapien Neanderthalis. And when I was in college, that's what was taught, Schwartz said.
Hey, can you start right there?
Dude, it was only later. It just hold your thought, James. I want to just get through it so we can see what the conclusion is. Can you hold your thought?
Yeah, go ahead.
It was only later in the 1970s and 80s that Neanderthals were reclassified as their own species on new analysts, and that remains the most common designation seen today. But a 2010 research based on 3 individuals and compared it with that of modern humans. The authors found hints of Neanderthal signature in human genome, suggesting that Neanderthals mixed with modern human ancestors at least 120,000 years ago. Dozens of papers since confirmed this and found that around 47,000 years ago, mixing occurred between multiple generations of 7,000 in time. The implication is clear. Neanderthals and humans were interbreeding, and evolutionary biologists and Homo sapiens also interbred with other groups of early hominids, right? The Denisovans. It is possible then that all 3 could represent different versions of the same species, he said. That's possible. This is 2524, right? And people have to build a narrative.
So how does
have noticed
speciation
differences in stature of skin. I want you to deal with what they saying, right? I don't want you to ask another question.
But come on, dude,
can you identify what they said?
You reading the
what does that have to do with your
right here? I'm on here.
What does that have to do? I'm not saying that, but you. What does that have to do with? It's on the topic, right? Because we're trying to make a distinction.
Like not letting me talk, dude, and I'm on here to talk to you, bro. Am I not? Am I on here?
I'm letting you talk. You asked me a question, James.
How do you? What is speciation? How does something speciate within the same thing? Do you know how?
James, so now you got to let me talk. So I'm going to answer your question, right? Because now you're going to a different question, right? But the question was how Homo sapiens and Neanderthals is classified. This article went through the whole thing and explained how it was classified and how they are coming to a new classification of Neanderthal, which was the conversation that we was having. And now you want to talk about something else. So I would appreciate it if you would deal with what's on the screen and if you ask me questions concerning the article, because I don't say you don't. I'll tell you you don't have to, but we have a question that's already on the table, right? So let's deal with what classification, right? Is what this article is expounding on. And if you can't expound on what the article is talking about, then there's no need to go to a different subject.
Because the article is talking about how do they identify different species. Am I making this up? And I'm trying to talk about how do something that was once the same turn into 2 different species. Do we understand that? It's based on divergence of time. So they said that Homo sapiens was in Africa away from Neanderthal for 400,000. That allowed enough time for speciation. And so you're saying science, they shouldn't even be saying that. That ain't. So if that's the case, we don't have nothing to do with primates like chimpanzees and that 98%. That's due to speciation of 2 million years. So you saying that's not true? Go ahead, I'm muting now. That's all I want to ask.
Right. So let's talk about speciation, right? Because this right here should answer your question, right? Because there's new notions of it, right? The implication is clear. Neanderthals and humans were interbreed. An evolutionary biologist from the University of Spain added that Neanderthals, Homo sapiens, also bred with other groups of early hominids, which is a whole nother group, and they're not supposed to be able to do that. The Denisovans. It is possible then that all 3 could represent different versions of the same species. So I understand what you're saying, James. That is how they say speciation occurred. But this from 2025, 2024, hold on, let me go back up. As saying they are looking at it different. This is from 2024. So yes, you are right. But this also is saying that it could be looked at in a different way. And we're not saying that is wrong. We are saying the way that they are interpreting it, right, could be interpreted a different way. Did I just make that up? So the same scientists pointed to modern humans as an example. People around the world have noticeable differences in stature or skin. hair, and eye color, but were remarkably the same from a genetic standpoint. The amount of genetic variation between two individuals is only about 0.1%, meaning that the only one base pair of out of 1,000 will be different. In comparison, the 2010 paper showed that the Neanderthal genome was 99.7% identical to that of the 5 present-day humans, right? To have big differences in morphology.
Hold on, what you mean 5
does not
present-day
mean
human? What did you mean by that?
you have to have a big difference in genetics.
Hold
It only
on,
just
dude. What
means
you
you
mean?
have
What
differences
5
that we
present-day
are
humans?
different species. He's saying it right here.
Read it again, because I didn't understand what that meant. You mean 5
The what?
present-day human? What does that mean?
What?
Go ahead.
Let me blow it up.
Yeah, you said 5 present-day humans. What does that mean? Identical to that of 5. Maybe he talking. Okay, so he's saying. Oh, so he's saying that. Oh, he's talking about 5 present-day. And what does that mean? Or maybe he's talking about you use 5 present-day humans, and he would be 97%.
Yeah, that's what he's. Yeah,
okay. No, I was just trying to get context. You're like, I can't get no kind of. You just gotta read through shit. I can't never get nothing out of this. That's crazy. But go ahead.
I just stopped and let you read it.
What I'm just saying.
I mean, James, you like, did I say anything against you? Tell me what I said.
I understand what that meant.
No,
go ahead.
Tell me what I said.
You breaking up, dude. You say what?
But I didn't say nothing about you interrupting me that time. I actually stopped and tried to find what you was talking about.
Okay, go ahead. That's what you're saying. Okay, we will keep going.
I
then.
did
I just
not
want to know
try
what
to
that
stop
was.
you from trying to figure it out.
Well, that's cool, dude. Keep going. I just want to know what that was.
People around the world have noticeable differences. The amount of genetic variation between two individuals, we already went there. To have big differences in morphology does not mean you need to have a big difference in genetics. It only just means you have some differences in specific genes, said this biologist. So the idea that they were different species doesn't make any sense to me as a geneticist. This is a geneticist talking from 2025. Schwartz doesn't think genetic evidence has necessarily settled the debate, but he has no misgivings about the rigor of the work the other groups have done. Moving forward, he advocates for an interdisciplinary approach that doesn't position genetics as the final say. We need a holistic approach, and we can't keep pitting one discipline against another. He said we have to get together to figure it out. So genetics is not the final say. And we can have different in genetics and be the same thing, or we can have the same.
Hold up. Read that last one. We say, damn, you breaking up. I don't know if you can hear me. Damn, that's crazy.
Yeah, I can.
Now read that last sentence where he was talking about.
I'm gonna go back to it. All right. Well, oh shit, this ain't the one. So let me go back.
Go back down where you was at.
All right, I think that's a whole different article. Let me find the one that I was on. This is this one right here. All right. So you talking about this right here? Can you see it?
Hold on. Yeah, but I
2010 Discovery took things up.
Was you at? You right back where you was at before?
This is exactly where I was at. I didn't.
Okay. Yeah.
I didn't. This.
Yeah, I just want you to read that. I think it's right there where it say, but in 2010, Discovery shook things up yet again. Yeah, right there. Read
but in 2000. But in 2010, the Discovery shook things up yet again. An international team of dozens of researchers published the first draft of the Neanderthal genome based on 3 individuals and compared it with that of modern humans. The author found hits of Neanderthal signature. He read this. That's what he was talking about. At least 120,000 years ago, papers have since confirmed 47,000 years ago mixing. Yeah, we already was right there. So we was about right here then.
Let's forget it because I
Who's
don't
up
think
in
we're
here?
gonna get back to where we was at. That's messed up.
Exactly where I ended it off right here.
You think so?
So here we are right here. This is the next thing. Because remember I said, because interdisciplinary
Yeah, now
approach.
scroll down a little bit.
Asking me? Are you asking me that I think so? Did you ask me that? I'm asking a geneticist. The geneticist said that, bro. Now, I don't think he BSing. So you want me to read this part? Because you said you
Yeah,
where
wherever we was at. If you saying this is where we was at, continue reading right there or wherever. If that's it.
This is exactly a 2024 paper. Meanwhile, argues that Homo sapiens and Neanderthals to be classified as different species, so we can better understand human evolution history. While the two came from the same parent population in Africa, Neanderthals entered Eurasia at least 400,000 years ago, giving them ample time to evolve separately, including better ways to survive in a cold and less sunny climate that altered the genes and appearance that authors wrote. Just let me go to the end of the sentence. Yeah.
Okay, so that's what I was talking about right there. That 400,000 years, just like the chimpanzee and bonobo, the Congo River separated them for 1 million years, and that allowed for speciation. The same thing happens within us as well. We're not different from any other primate, right? If you separate for long enough, you can speciate, right? Would you agree with that or no? It has to be a certain, because you know when Neanderthals and Homo sapiens started to procreate with each other.
James, you asked me a question and you don't got to let me answer.
You didn't even start talking yet before I.
So let me answer the first question first.
Damn.
You asked me the question, do I agree with speciation?
Hold on, I was still going.
Did you not want me to answer that, or was that a rhetorical question?
Go ahead.
I asked you, did you not want me to answer that question? All you had to say was no.
No, go ahead, man.
You asked me the question.
Answer the question.
So you asked me the question, do I agree? I'm trying to go ahead, but you keep cutting me off.
We must ask me the question.
We got a delay,
dude. Hold on, dude. We got a delay. We got a delay. Just remember that, because something's going on. My voice gets to you later. Yeah, that's what it is. We got a delay. Go ahead.
Okay, that's what it is. That's what's up. So you asked me, do I agree if that is speciation, if that's what they call speciation? I agree with that. But what the geneticist in this paper is challenging the notion that these are actual different species, because just because you have morphological differences doesn't necessarily make you different. And just because you have genetic changes doesn't necessarily make you different. I already went over in my presentation that you can have epigenetic differences that don't make you necessarily different. You can also have species that come from a foundation species that have different genetics, but these things we already know they're the same, right? You can have a plant that's a clone and put them in two different environments, and that they will come up looking different, completely different, but they are the same. You can have a genetic mutation from a foundation population, but you are still the same. You're still able to interbreed. So the question that they're trying to deal with, just because you have genetic differences, does that substantially make you different? This is what's in question, James. This is what the whole article is about.
Yeah, I know, but what I understand is like how people confused when you know the genetics causes different things to speciate. Like we know that in the feline family, the lions and cats was both the same at one point, but then they speciated off. So what's the problem? So you saying that lions and cat ain't on the same feline family? A lion and a tiger? Is that what you're saying? And we know that they procreated and created a liger.
I don't know how you got
so that. They're the same species, huh? A lion and a tiger the same, huh? Because they can procreate. No?
I don't know, but so I was just bringing to the forefront what the geneticist said about humans and human taxonomy and how it's kind of the lines are blurred. And so I just want to, I hope that brought a pretty good understanding. How much time you got, James? You got time to look at something else?
Yeah, we can, but I wanted to show something real quick too, dude. So I don't want to just leave you dry.
All right.
I wanted to show something too.
No, you good.
Right. So let me share my screen real quick.
Let me see.
Bam. Let me know when that's up.
All right.
Can you see it?
Yeah, let me get my face at the screen. I don't know. I think I gotta stop sharing my screen. I stopped sharing my screen.
So what do you want me to do?
I see it. There we go.
Okay.
I want you to blow it up.
I can't, dude.
All right, it's cool.
Look, see, you see what's happening? Can you see that?
Yeah, I can see it. Can you just scroll? Yeah, there you go. That's way better.
Okay, I ain't know. Well, anyway, so check this out. Now at the top right here, it says the name of this genetic paper right here is the contribution of Neanderthal integration to modern human traits, skin and hair pigmentation, 2022, right? So anybody in the sound of my voice can look this up. But it says hair and skin pigmentation. One of the most well supported candidates of adaptive integration in a large Neanderthal integration haplotype at 50 base pairs. It says found at a high frequency at 70% in European encompassing BN2C. So that's the gene that they got from Neanderthals, the 70% that's in Europeans today. You see that? It says the gene is on chromosome 9. BNC2 encodes a zinc finger protein that expresses whatever this creatine is, like skin lesions that they get. They got that from them. And it says it has been associated with skin pigmentation and freckles in Europeans. Another strong candidate of adaptive integration spans the POU2F3 gene on chromosome 11. So see, they going directly to each chromosome that this shit is on. It's not human. It says these genes encode a transcript factor expressed in epidermis and is responsible for mediation of the quercetin, or however you say this word, proliferation and differentiation. While nearly absent in Europeans, Neanderthal haplotype encompasses this gene and is present in a high frequency in Eastern Eurasia. So they saying that this gene ain't even in the European. It's off in Eastern Eurasia. But this is what it encodes for. It's saying it is code. Damn, what did I do? I was trying to move. It's saying this gene encodes for different factors in the epidermis, which is for creatine as well. It says another example of adaptive integration in a 200 base pair long haplotype on chromosome 3 encompasses the HAAL2 gene involved in cellular responses in UV radiation and changes in pigmentation. The HAAL2 expresses decrease significantly after exposure to UVB irradiation. It says disputing tissue repair. What is that? Disrupting tissue repair processes and ultimately leading to sunburn. This Neanderthal integration haplotype is found at high frequency in East Asians, not in European. So they're just talking about the different kinds. But but it says, okay, a 29.7% base pair Neanderthal integration haplotype encompasses the OCA2 gene on chromosome 15 is found at high frequency at 60% in Eastern Asians and intermediate frequencies of 20 to 30% in Europeans, South Asians, and Malaysians. The A2A gene encodes for transmembrane proteins that impact skin, hair, and iris pigmentation. That's the eye. It says specifically the Neanderthal introgression allele associated with blue eyes introgression and blonde hair and red hair color was under selection in modern humans. So they're saying that they got this from them. You see what I'm saying? It says other examples of Neanderthal adaptive introgression, including the KRT71 and the KRT80, two genes in types one, I guess it's 2 creatine gene clusters in chromosome 12, a 100 base pair archaic haplotype encompassing the gene KRTL7 has a frequency of 65% in Europeans, 42% in East Asians, and 89% in Southern Asians. Whatever, this creatine gene is for another one. And what is this saying? It says it's found at high as 20 to 60% frequency in near remote oceanias, intermediate frequencies in Europeans. So what I'm saying is these genes that they got from these Neanderthal, from the Neanderthal sample that they got, they say they found this introgressed off into European people. Not, you know what I mean? So what do you think about that?
I mean, it say what it say. It's saying that, you know, Europeans got a lot of Neanderthal traits in them.
Yeah, genes. Which
so what are you trying?
Those genes turn into traits that we can
exactly.
phenotypically see. So I'm just saying that they know that where they got the genes from is what I'm saying. They didn't get them from modern humans.
For sure.
Yeah, those are not modern human genes. And those genes later turn into the SLC genes that we see. And they saying that kind of like you said, they still are trying to figure this out. So I would agree with you on that, dude. They still trying to figure this out. But what I'm saying is they also have the genetic to go along with the archaeology and everything else that's encompassing. You know what I mean? They can measure they can measure when those particular alleles come back into Africa because they're saying they're not African in origin, right?
Yeah, and I read it. So that's what I want to that's what I was about to touch on. I'm about to Google something concerning that right now. Did you stop sharing your screen?
I already did, I thought.
Yeah, I just asked you if you did or not.
Okay, I thought you seen. Yeah, I stopped the long. I already
cool.
Stopped.
All right, so I'm gonna try to look up something right quick. So this is what I'm gonna put. Is Neanderthal DNA a subset of African?
By subset, what do you mean? Not the same?
Well, because like this, because like, so African is the base population, right? Africans is the base population. Is Neanderthal because all of the potential on what could be starts in Africa, right? As far as DNA. So I'm trying to figure out how to word that good, because the way that they try to frame it, right, that it originates in Neanderthal because that's when it was expressed outside the continent of Africa, but all the potential that could exist actually originate in Africa. You know what I'm saying? So these things happen outside of the continent, but you got to keep in mind, these were once upon a time, they were so-called Africans and just mutated outside the continent. Just like when you was having a conversation earlier that said, just because somebody goes to Madagascar, African go to Madagascar and change to and have a genetic mutation, that don't necessarily make them different. Just because somebody go to Arabia and have a mutation don't make them different. But then you would say that if some introgression come in and necessarily make them different, nah, because really it's still a further down the line genetically mutated African. That's how I be seeing it. Now, that's not to say that there are not distinctions, because we are labeling them based on the distinctions. But how substantial are these distinctions is what's in question. right? Are they totally different species? Are they just genetic variation?
That's arbitrary. That's arbitrary, dude. We don't know. That's what the fuck they are. But we got to go with the taxonomy that they already came up with. We can't, you know what I'm saying? If they want to change it, then what we gonna do? We gonna go with the change, right?
Exactly.
See what I'm saying? So right now, where we at is there a different species right around. And then until they change it, when they change it, if we change it basically based on what they say, we're gonna agree with them and say, okay, now they're different species again, right?
Yeah, I agree. Me myself, I'm gonna stand on the new way of how they trying to qualify it. You know what I'm saying? Even though that you're right, I will say that the majority of the science is still dealing with the old notions on how they classify Neanderthal, but I would say that things are more closely related than we think. You know what I'm saying? This is how I see it, James. I see it as a continuum, right? It's not separate things. Even though that we see these differences, that don't mean it's separate things. It's just variety of how we look at humans today, whether it's the pygmy, the aboriginal, the thing, and they have genetic differences, right? Even though we are closely related, we are 99.9% the same. But if you go into the point, some is going to be different. Just like whenever we dealing with Neanderthal, we only 0.2%. You know what I'm saying? Different.
Yeah. So basically, you saying, do you basically a chimpanzee and a bonobo are the same motherfucking thing, basically.
I mean, I don't necessarily. I wouldn't.
I would agree with that if that's what you're saying.
Well,
if you saying if you just saying it don't really matter, then fuck it. Chimpanzees and bonobos are the same because taxonomy is just a
no, I ain't trying. Like how like I would say like us and chimpanzees are obviously different, right? Okay. You know what I'm saying? Substantially different. But whenever you talk about what our closer relatives, right? How much of a difference, right? That's what the article was talking about, like how much substantial differences, because they said like it's species in between Neanderthal and Homo sapien that we don't know that it exists. There could be an array of species. It could be one species. It could be 100 species. You know what I'm saying? So that's how you know
what we're seeing is on the genetic level. What we can identify is only what they can see on the genetic level right now. Now they said that they found some archaic integration within Africa, right? You know that, right?
Absolutely.
So what I'm saying, it ain't just I'm trying to just say that they found some archaic integration only outside of Africa. They found it within Africa, but that don't matter in the context of trying to find out what they labeled as non-African in Africa. Because the fight that we fighting is a fight for they trying to say that non-Africans, what they label in genetics now, James ain't doing this. Non-Africans was in Africa earlier than what they supposed to be, but we can see it on the genetic level to say when they came in. And if we don't want to acknowledge that genetic level, then yeah, these motherfuckers been in Africa for 20,000 years. Europeans.
Who you saying that? Who's saying that?
I'm just saying that we're not acknowledging what we can see off in genetics, because that's what Ngozi does. He's not acknowledging that we can see that integration that makes us different from all non-Africans. So he's saying that that shit don't mean shit. It ain't nothing but 99.7%. It's all the fucking same. And what the fuck does that mean? That's what Ngozi's argument is. You see what I'm saying? So we don't acknowledge that. If we don't acknowledge this zero, if we don't acknowledge this 0.4%, then we fuck. Basically, is what I'm saying. We got to acknowledge it, or we might as well just say the Europeans been in Africa forever. So yeah, we can have it either way.
No, for sure. No, we definitely got to. No, we definitely got to acknowledge it. I mean, that's how we got to make the distinctions in order to talk about different things. Because if we don't create the labels, we can't talk about different things. So we got to label them somehow.
So we
you know
screwed.
You
know what I'm saying? We screwed.
Right. Shit. Yeah.
That's all it is. Dude.
Let me see.
If I say something, remember we on the delay, dude. So I ain't trying to talk over you because it seemed like that's what's going on. It seemed like when my voice get done, then I just getting to you later. See?
Right. I think you're right about that. That's how we kept missing, and that's how we was talking over each other and shit like that. So I think you're right about that.
I'll pause a second.
Pull out.
before I say something. After you say something. But yeah, man, no offense or nothing like that. We
And
on the
I'll
same
do the
team,
same.
nothing.
That way we don't get mixed up. For sure.
Yeah, you
All
right.
right. I don't know. Did you get a chance to check out my video?
Yeah, I was watching it. I started watching it. I was riding to the store. I didn't see everything, but I seen most of it.
All right. I wanna go through it, if you don't mind.
Oh, you talking about
Man,
this video? No, I didn't see this one.
The trouble with labels. Did you know that there is no scientific consensus to the definition of the word species? How in the world do scientists know if they're even talking about the same thing? I will try to clear this up, but it's gonna be tricky.
Just stop me whenever you want to jump in, James.
Hold on to your seats. One of the issues is that when we find fossils, they don't have pretty little tags hanging off of them that says Homo heidelbergensis to let you know what it is that you have found. And since that is the case, humans take it upon themselves to label and categorize them. And this is what we call taxonomy. The trouble with taxonomy is scientists don't agree as to where one species begins and another ends. So the question then becomes, who gets to decide, and by what methodology do we organize mankind? Different cultures have different ways of organizing and structuring mankind according to their own perspectives, which makes the issue even more complicated. The species problem is considered one of the oldest, if not the oldest challenge in biology, which is the ongoing difficulty and disagreement among biologists in defining and identifying species. It's the challenge of finding a universally accepted definition of species that applies to all living organisms and reflects how they are classified. You would figure since the most familiar plants and animals we know are of different species, you would think there is a scientifically accepted method. So then the question obviously becomes, what is the method since we have all these different species? First off, let's deal with some of the definitions we do have. The 3 definitions of species. The word species can have different meanings, which sometimes overlap or even conflict with each other. Let's break them down. 1. Species as a taxonomic rank. This is like a label in a filing system. Species is just the name of a category used in scientific classification. For example, kingdom, Animalia, phylum, Chordata, class, Mammalia, order, primates, family, Hominidae, genus, Homo, species, Homo sapiens.
Hey, if you saying something, I can't hear you.
I said, my bad. I said it's really a good video. I go and break it down. I get your DNA at the end though too, but it's a 30-minute video, and I want to put something in my belly. I got home from work and I haven't eaten yet. But if you ain't doing nothing tomorrow, I'll hit you up tomorrow. Maybe.
Right on.
Yeah. So, but I just want to say a peace to you. I appreciate you for showing up, and we always on the same team, even if we disagree. It's okay for us to disagree. And I just want to say to the people, man, I hope you guys like the presentation, and I also hope you like the point that I was getting. Like, you know, the taxonomic definitions are in question, and we need to always question science. And science is always ever evolving, so it's not bad to actually question these things, right? And that's what we do at the Principles. We deal with the principles of things, right? We want to get to the core. So we starting at the beginning, and we going to build up to the top. All right. Peace.